How does a modern Airbus A330, with advanced computers, experienced pilots, and over 300 people on board, suddenly run out of fuel mid-air? A silent aircraft gliding at 39,000 feet, no engines, no power, just gravity. A hidden technical mistake made days earlier that no one noticed, and a decision in the cockpit that unknowingly made everything worse. Mayday, mayday, we have lost both engines due to fuel starvation. We are gliding now. Think about that for a moment. A state-of-the-art aircraft reduced to a powerless glider over the Atlantic Ocean. To understand how this happened, we need to go back to where the journey began. It is August 2001. Air Transat Flight 236 departs from Toronto, heading toward Lisbon. On board, 306 passengers and crew. The aircraft is a modern Airbus A330, equipped with advanced systems designed to monitor every aspect of the flight. The pilots are experienced, the weather is clear. The journey begins like any other routine transatlantic flight. For nearly 5 hours, everything goes exactly as planned. Passengers relax, the crew follows standard procedures. The aircraft performs flawlessly. And that is exactly what makes this story so difficult to understand. Because when something finally goes wrong, it does not look serious at all. But that small moment would soon lead to one of the most extraordinary aviation incidents ever recorded. Have you ever noticed how the most serious problems often begin with something small, almost insignificant? That is exactly how this situation started. 5 hours into the flight, the cockpit receives an unusual warning: low oil temperature and high oil pressure in one of the engines. Now, this combination is extremely rare. In fact, it does not behave the way normal engine issues typically do. The pilots pause. They check the systems. They review the manuals. Nothing seems to match what they are seeing. So they do what any trained crew would do. They contact ground maintenance. But even from thousands of miles away, the response is uncertain. There is no clear explanation, no immediate solution. And slowly, a conclusion begins to form. Maybe this is just a faulty sensor. Maybe the system is giving incorrect data. And that assumption changes everything. Because from this moment forward, the crew begins to question the reliability of their own instruments. Then, about 20 minutes later, another warning appears. This time, it shows a fuel imbalance. One wing has noticeably less fuel than the other. Now, this is something the aircraft is designed to handle. The procedure is clear. Transfer fuel between tanks using the crossfeed system. So the pilots follow the checklist. They activate the crossfeed. And for a moment, everything seems under control. But here is the critical detail. What they are seeing is not just a system imbalance. It is the early sign of something far more serious. The warnings were real, but they were interpreted as technical glitches. And this is where human judgment meets machine complexity. Because when systems appear unreliable, even correct information can be ignored. But while the crew believed they were correcting a minor issue, something far more serious was unfolding, completely unseen. Now here is where it gets interesting. While the pilots are focused on balancing fuel, the aircraft is actually losing it. Rapidly, unnoticed. A fuel leak has developed in the right engine, and the system has no direct warning to indicate that fuel is disappearing faster than it should. Think about that. The aircraft can measure how much fuel is on board, but it cannot immediately detect that it is leaking externally. And the crossfeed system, meant to solve the imbalance, is now making things worse. Instead of isolating the issue, it allows fuel from the left side to flow toward the right, where it continues to leak out. At this point, the situation becomes a race against time. The crew performs another fuel check, and this time, the numbers do not add up. The fuel remaining is far lower than expected. Now the realization begins to set in. This is not a sensor issue. This is not a computer error. This is real. The aircraft is losing fuel. The crew requests the nearest available runway. The answer comes back, an airbase in the Azores, hundreds of kilometers away. Reachable, but only if the remaining fuel holds. So they continue, monitoring, calculating, hoping, but uncertainty remains, because even now they do not fully understand the scale of the problem. And in aviation, incomplete information can be just as dangerous as no information at all. By the time the crew understood what was really happening, their options were already slipping away. What happened next shocked even experienced aviation experts. The first engine stops, then the second. Within minutes, a modern jetliner becomes something entirely different. A glider. At 39,000 feet above the Atlantic Ocean. No engines. No normal power systems. Just altitude and time. Inside the cockpit, everything changes. Emergency systems deploy automatically. A small device called a ram air turbine extends into the airflow. It provides limited power